Good day, dear learners! Welcome to another episode of Learn Math with Doc Gilma. Are you ready, class, for the next lesson? So if you're ready, just sit back, relax, and listen carefully to the topic to be discussed for today. Alright, class, let's begin! The topic I will be discussing for today's lesson is all about parallel lines cut by a transversal line. What are parallel lines? Parallel lines are coplanar lines that do not intersect. Consider a line here, and we name this line as line L, and another line here, and we name this as line M. What is a transversal line? When we talk about transversal line, it is a line that intersects two or more coplanar lines at two or more distinct points. Consider line L and line M. Line L and line M are parallel lines. And a line T intersects line L and line M. Take note, line T is a transversal line since it intersects line M at point A and line L at point B. So take note of that. Parallel lines and transversal. Consider two lines here, line L and line M, which are parallel line and a transversal line T. From here, there are actually 8 angles that are formed by a transversal line cutting two parallel lines. So we have angle 1, angle 2, angle 3, angle 4, angle 5, angle 6, angle 7, and angle 8. So these are the 8 angles formed by a transversal line cutting two parallel lines. Angles 1 up to 8. The angle pairs formed by a transversal line cutting two parallel lines are interior and exterior angles, pairs of corresponding angles, pairs of alternate interior angles, pairs of alternate exterior angles, pairs of same side interior angles, pairs of same side exterior angles, pairs of vertical angles, and linear pair angles. Consider interior angles. Interior angles are angles formed inside the two parallel lines that is cut by a transversal line. Consider line L and line M, a transversal line T cutting two parallel lines L and M with two distinct points. The interior angles formed here are angle 3, angle 4, angle 5, and angle 6. Consider exterior angles. When we talk about exterior angles, these are angles formed by two parallel lines cut by a transversal line outside the two parallel lines. Consider line L and line M, which are parallel line cut by a transversal line T. The exterior angles formed here are angle 1, angle 2, angle 7, and angle 8. As you can see, these angles here are outside of the two parallel lines. Angle formed outside the two parallel lines cut by a transversal line. Pairs of corresponding angles. Consider two parallel lines here, line L and line M, cut by a transversal line T. The pairs of corresponding angles formed here are congruent. So we have angle 1 and 5, angle 3 and angle 7, angle 2 and angle 6, angle 4 and angle 8. These pairs of corresponding angles are congruent. Take note of that. Pairs of alternate interior angles. Consider two parallel lines here, line L and line M, cut by a transversal line T. So as you can see, with two distinct points of intersection, the pair of alternate interior angles formed here are angle 3 and angle 6. Take note, pairs of alternate interior angles are congruent. We also have angle 4 and angle 5 are alternate interior angles. Pairs of alternate exterior angles. Consider two parallel lines here, line L and line M, cut by a transversal line T with two distinct points. The pairs of alternate exterior angles formed here are angle 1 and angle 8, angle 2 and angle 7. Take note, pairs of alternate exterior angles are congruent. Pairs of same side interior angles. Consider two parallel lines here, line L and line M, that is cut by a transversal line T with two distinct points of intersection. The pairs of same side interior angles are angle 3 and angle 5, angle 4 and angle 6. Take note, pairs of same side interior angles are supplementary. Consider pairs of same side exterior angles. Given two parallel lines here, line L and line M, that is cut by a transversal line T with two distinct points of intersection. The pairs of same side exterior angles formed here are angle 1 and angle 7, angle 2 and angle 8. Take note, class, pairs of same side exterior angles are supplementary. Pairs of vertical angles. Consider two parallel lines here, line L and line M, cut by a transversal line T with two distinct points of intersection. The pairs of vertical angles formed here are angle 1 and angle 4, angle 2 and angle 3, angle 5 and angle 8, angle 6 and angle 7. As you can see, these pairs are all vertical angles. Take note, pairs of vertical angles are congruent. Consider linear pair angles. Given two parallel lines here, line L and line M, cut by a transversal line T, which intersects line L and line M with two distinct points. The linear pair angles here are angle 1 and angle 2, angle 3 and angle 4, angle 5 and angle 6, angle 7 and angle 8. So there are 4 pairs of linear pair angles. Take note, linear pair angles are supplementary. We are done with the concepts of the angle pairs formed by two parallel lines cut by a transversal line. This time, we're going to apply the concepts we just have discussed for today. Identify the measures of the angles formed by parallel lines cut by transversal line. Consider line L and line M cut by a transversal line T with two distinct points of intersection. Angle 2 is given, which is 50 degrees. We're going to identify the measure of angles 1, 3, 4, 5, 6, 7, and 8. If we are to determine the measure of angle 1 based from the given measure of angle 2, which is 50 degrees, take note, angle 1 and angle 2 are linear pair, meaning they are supplementary angles. So therefore, angle 1 is just equal to 180 degrees minus 50 degrees. So angle 1 is simply equal to 130 degrees. Since 130 degrees plus 50 degrees is just equal to 180 degrees. Angle 1 and angle 2 are linear pair, which are supplementary angles. Take note of that. Consider again line L and line M here, cut by a transversal line T with two distinct points of intersection. So we have angle 2, which is 50 degrees. We are to determine this time the measure of angle 3. What is the relationship between angle 2 and angle 3? Yes, angle 2 and angle 3 are vertical angles. When we talk about vertical angles, the measure of the pair of vertical angles are congruent. So therefore, measure of angle 3 is just equal to 50 degrees. Since angle 2 and angle 3 are vertical angles, their measure are congruent. Consider again line L and line M here, cut by a transversal line T with two distinct points of intersection. Angle 2 is given, which is 50 degrees. This time, we're going to determine the measure of angle 4. To determine the measure of angle 4, it is very important for us to identify the relationship of angle 2 and angle 4. Angle 2 and angle 4 are linear pair. So meaning, they are supplementary. Therefore, the measure of angle 4 is just equal to 180 degrees minus 50 degrees, which is simply equal to 130 degrees. Again, consider line L and line M cut by a transversal line T with two distinct points of intersection. Given angle 2 is equal to 50 degrees. This time, we're going to determine the measure of angle 5. To determine the measure of angle 5, it is very important to connect the measure of angle 5 to angle 1. Take note, class, angle 1 and angle 5 are corresponding angles. And take note, corresponding angles are congruent. The measure of angle 1 is 130 degrees. So therefore, the measure of angle 5 is also equal to 130 degrees. So take note of that. Either line L and M cut by a transversal line T with two distinct points of intersection. Angle 2 is 50 degrees. This time, we're going to determine the measure of angle 6. What is the relationship between angle 2 and angle 6? Yes, they are corresponding angles. Corresponding angles are congruent. So therefore, the measure of angle 6 is equal to 50 degrees. Consider two parallel lines here, L and M, cut by a transversal line T with two distinct points of intersection. Given angle 2 is 50 degrees. This time, we're going to determine the measure of angle 7. What is the relationship between angle 2 and angle 7? That's right. This pair of angles are alternate exterior angles. Take note, class, alternate exterior angles are congruent. Therefore, the measure of angle 7 is also equal to 50 degrees. Take note of that. Consider line L and line M cut by a transversal line T with two distinct points of intersection. Angle 2 is 50 degrees. This time, we're going to determine the measure of angle 8. What is the relationship between angle 2 and angle 8? Yes, this pair of angles are same side exterior angles. Take note, same side exterior angles are supplementary. Therefore, the measure of angle 8 is just equal to 180 degrees minus 50 degrees, which is just equal to 130 degrees. So take note of that. Before we end our discussion for today, let me first read to you a simple passage coming from the Bible. Ephesians chapter 3, verse 20. Glory to God, who is able to do far beyond all that we could ask or imagine by His power at work within us. Take note, class, skills are developed through constant correct practice, and there will always be a room for improvement. That's all for today. Stand by for more lessons. Stay safe, everyone, and may God bless us all.